Okay, children, now we are going to discuss how do we write the chemical formula. So that is regarding the formula, equation and calculation lesson. The first we are going to discuss how do we write a chemical formula. It's like this. This is highly connected to the periodic table. I guess that now you have the periodic table with you. If you have the periodic table with you, this process will be easy. Right. It's like this thing. Now, you know that your teacher write water is H2O. Your teacher write water is H2O. Why can't it be H3O? Why H3O is wrong? Right? Your teacher write carbon dioxide is CO2. Why can't it be CO3? Right? Your teacher write sodium chloride is NaCl. Why not it NaCl5? So we are going to find the answer for that case. So why teacher write water as H2O? What is the reason why the teacher write carbon dioxide as CO2? This is highly connected to the periodic table. So you want to have the periodic table with you now, right? Okay, we'll see that how that things happen, right? So now look at here. Now when I concern this periodic table, if you have the periodic table with you, that's better, right? Now we had a question, why water is H2O? Water is made out of hydrogen and oxygen. Water is made out of hydrogen and oxygen. If you see that periodic table, right? If you see the periodic table, you can see the hydrogen's valency is 1. Let me to show that hydrogen's valency is 1, right? Give me 1 minute. So now you take this periodic table. Now, when we take the periodic table like this way, you turn the periodic table, then I will explain how it happens. Right. Now, when this periodic table is concerned, you see the hydrogen here, right? Sometimes in your periodic table, hydrogen may be in the group 1. Hydrogen is in, normally it is atomic number is 1. Hydrogen's atomic number is 1. So we write the configuration as 1. So the valency of hydrogen is 1. So hydrogen's valency is 1. So we write the valency of hydrogen here. What the valency? 1. Similarly, when I consider the oxygen, oxygen is here. You see that oxygen is here. Oxygen is, you see the periodic table, oxygen's atomic number is 8. So how do we write 2 and 6? Oh, oxygen has how many outer electrons? It has 6 outer electrons. 6 outer electrons means we concern how many need to be 8. How many need to be 8? We always think how many need to be 8 because these atoms get satisfied if they have 18 outer. They always has a trend to be 18 outer. To be 18 outer or 0 in outer. That's for the stable cases. 18 outer or 0 in outer. So here, if that gain another 2, it has 18 outer shell. So the oxygen's valency is what? 2. Now we got the valencies of these two. What we have to do then? We have to interchange this valency. So hydrogen get the valency of oxygen. It is H2. Hydrogen get the valency of oxygen. Oxygen gains the valency of hydrogen. That is 1. So water is H2O. No chance to be H2O3. No chance to be H3O. Only the answer is H2O. Understand that? I guess you understood it. Right. We go to my second exam. Right. Something like this. Now, why magnesium chloride is like that? Okay. In words, we write magnesium chloride. Magnesium chloride. If you notice that periodic table, magnesium we write Mg, chloride we write Cl, chlorine or chloride is Cl minus H. Okay, magnesium atomic number is 12. The students, those who know that electronic configuration, magnesium's atomic number is 12 in the periodic table. You find in the periodic table it's 12. Right. So how do you write that? 2, 8, 2. Oh, what's easy? Being 0 or being 8? There's a trend. The trend is to be 0 in the outermost or to be 8 in the outermost. If that 2 is removed, then it is 0. If another 6 is gained, then it is 8. So that will be stable. Either it release 2 or gain another 6. So releasing 2 is easy. Magnesium has 2 outermost. So the magnesium's valence is 2 because to be stable, magnesium release 2. Chlorine. Chlorine is 17. Oh, how do you write that? 2, 8, 7. Oh, how many in outer? 7. Oh, how can it be stable? If 7 release, then 0 are stable. Oh, another 1 gain, then totally 8. Then also stable. What is easy? Removing 7 or gaining 1? Gaining 1 is easy. So the chloride's valence is 1. Okay, I got the valences. Now I have the duty. What my duty is? Interchange the valences. So magnesium gains number 1, chloride gains number 2. So magnesium chloride. Magnesium gains number 1, chlorine gains number 2. Magnesium chloride is MgCl2. Right? Okay. I go to my third example. Right. This time I will write aluminium oxide. Right? So how do you write aluminium oxide? We want to find the atomic number of aluminium and atomic number of oxygen and find the valencies of that and then interchange the valency. Very simple. Right. See this one. Aluminium atomic number is 13. How to write that? 2, 8, 3. Okay. Aluminium Al. How many outer electrons? 3. So it has two options. Release 3 and become fully empty. Or gain another 5 and becomes fully filled. Right? So what is easy? Removing 3 or gaining 5? Removing 3 is easy. So aluminium's valency is 3. Oxygen, oxide we write O2 minus, its valency is 2. So then now we will interchange. So how do you write aluminium oxide? Aluminium get the valency of oxygen. What the valency of oxygen? That's 2. Right. Oxygen gains the valency of aluminium. What the valency of aluminium? That's 3. So aluminium oxide is what? Al2O3. Like that, we write the chemical formula. So remember that if you have the periodic table, you can write a chemical formula for many of the compounds. We do not by heart the valencies in these elements in the periodic table. We do not by heart the valencies of elements in the periodic table. So that is how we write the chemical formula for the simple compound. If you have the periodic table, you can find the valency and you can simply determine uh, the valencies are. In here, you see this is group 1. All the group 1 people has the valency 1. Group 2, valency 2. Group 3, valency 3. Group 4, valency 4. Group 5, valency 3. Group 6, valency 2. Group 7, valency 1. Group 0, no valence. Right. So that way also you can find the valency. No need that even if the atomic number is there. As I write the electronic configuration, you write it. See what is more close, to be 0 or to be 8. So then you can determine what the valency is. Right. But this situation will be little complex if you come to this point. There are some set of groups. You need to remember that. And now I will write that groups, right? So what are those groups are? What are those groups are? Right. This one, OH minus. We call it is hydroxide. Its valency is what? CO3 2 minus. We call it is carbonate. Its valence is 2. HCO3 minus. We call it is hydrogen carbonate or bicarbonate. Valence is 1. NO3 minus. We call this is nitrate. Valency 1. PO4 3 minus. We call that is phosphate. Valency is 3. And the next one is NH4 plus. Valency is 1. Hydroxide, valency 1. Carbonate, valency 2. Bicarbonate, valency 1. Nitrate, valency 1. Phosphate, valency 3. Ammonium, valency 1. Got another one? Chloride, valency 1. Bromide, valency 1. Iodide, valency 1. Oxide, valency 2. Cyanide, valency 1. Sulfide, valency 2. Sulfide, SO3 2 minus, we call sulfite, valency 2. SO4 2 minus, we call sulfate, valency 2. These things need to be remembered. There are another 2G chromate, manganate, like so those things they are in the textbook, right? So then for an example, manganate, MnO4 minus, we call that is permanganate, valency 1, right? Likewise, there are many groups, but this set of groups is enough, I guess. So then, now if you remember these things, now we can write the chemical formula for little complex compound. I will erase these things, having idea that you have written down these things, and then you can notice what is the valency of each group. I'll come across again: hydroxide, carbonate, bicarbonate or hydrogen carbonate, nitrate, phosphate, ammonium, chloride, bromide, iodide, oxides, cyanides, sulfide, sulfite, sulfate, permanganate. Right. The next. Now I will erase these things. Right. So we see that how we use these groups to write their formula. Right. Just imagine I want to write sodium nitrate. So what I want to write, children? Sodium nitrate. See the periodic table. How can I write sodium? Na. Remember the earlier thing that I erased. How can I write the nitrate? NO3 minus. If you see the periodic table, you see the sodium's valency 1. I will say how I come to that. Sodium is atomic number. Sodium's atomic number is 11, 2, 8, 1. Oh, 1 electron out. So it removes 1 electron to be stable. So its valence is 1. Nitrate valency is this charge. What is the charge? -1. So the valence is 1. Don't take -1. We take the numerical value only. So we take 1. So we interchange that. So how did I sodium nitrate? Na get number 1. Sodium get number 1. When it is number 1, we don't write it. Sodium nitrate NO3, also nitrate gain number 1. We don't write it if it is 1. So sodium nitrate is this. Right? This is how the sodium nitrate. Write the sodium, its valence. Write nitrate, its valence. Now we interchange the valence. Now we got the answer. Right. I go to my second example now. Right. See that. How we write another one? Magnesium nitrate. Magnesium nitrate. Magnesium, how do we write? If you see the periodic table, magnesium is Mg. Mg. Nitrate, NO3 minus. Magnesium's valency. See that magnesium's atomic number is 12. So how do you write that 12? 2, 8, 282. So what's the valency? It removed 2 electrons. So the valence is 2. Nitrate valence is 1. So then what we have to do now? We want to interchange. Magnesium gains number 1. So we write it? No, we don't write. Nitrate, nitrate is NO3. Nitrate get number 2, right? So it's something like a 32. So what we are doing, children? So we put a brackets. We put a bracket like this. NO3 twice. MgNO3 twice is a magnesium nitrate. Magnesium, right? Nitrate, right? We write the magnesium's valency. We write the nitrate's valency. So these two valencies are interchanged. So magnesium gains number 1. So we don't write it. Nitrate gains number 2. So we write NO3 brackets and 2. I got another one, right? This time ammonium nitrate. Ammonium nitrate. Right. How do you write ammonium? Ammonium we write NH4 plus. How do you write nitrate? Nitrate we write NO3 minus. Ammonium's valency is the charge. It's 1. Nitrate valency is 1. So we interchange. Ammonium is NH4. That it gains number 1. So we don't write it. So NH4 only. This 4 is that instant it has a 4, right? So NH4 is that originally it has a 4. That valence interchange, then the number 1 comes here. See that number 1 comes, see that number 1 comes here. We don't write it as it is number 1. Nitrate is NO3. That also gain 1. So we don't write. So that's how the ammonium nitrate. Right. I got another one. So we go to aluminium nitrate. My fourth example, children. Aluminium nitrate. Right. Aluminium is Al. Nitrate is NO3 minus. Right. And aluminium's valency is 3. Nitrate valency is 1. Now this 3 charge is the valency. Charge is 1. Nitrate valency is 1. So we interchange. Aluminium gains number 1. We don't write it there. Then nitrate gains number 3. We put a bracket, otherwise it appears like 32. So that's how we write aluminium nitrate. Right. Then there's another case. Right. I go to my next example. How do we write the carbon dioxide? This time I come to carbon dioxide. Carbon dioxide. Carbon dioxide. I guess you can see that. Yes. Carbon is C. Oxygen is O. Carbon's valency 4. Oxygen valency 2. Oh, this one is little different. What's the difference there? Now you see that this 4 and 2 are two digits that they can further divisible. Can we divide it again? So we have to divide until we get the simplest whole numbers. So this 2 divided by 2 and 4 divided by 2. 2 divided by 2 answer is 1. 4 divided by 2 answer is 2. After we simplify like that, then only we interchange. So then, oh, carbon gains number 1. Oxygen gains number 2. So it is CO2. That's how the carbon dioxide becomes CO2. Right. I got another one. Then see that? The next thing I go to this magnesium oxide. Okay. I go to magnesium oxide. Magnesium oxide. Okay. Magnesium is Mg. Oxide is O2 minus. Magnesium's valency 2. Oxide valency also 2. That is can be simplified again. 2 divided by 2 and this 2 divided by 2 and it is what? Cancel off 1 and 1. So now only we interchange. So it is what? Magnesium gains number 1, oxygen gains number 1. So it is MgO is the answer. Right. Then the next one. That's how the magnesium oxide is. See that I write sodium oxide. Right. Sodium oxide. Sodium is Na, oxide is O2 minus. Sodium's valency 1, oxide's valency 2. Now we interchange. For this time, sodium gains number 2, oxide gains number 1. We don't write 1. That's how the sodium oxide becomes like that. I guess you can understand. Right. Then, now sometimes we have to write the chemical formula for the compound like zinc, iron, chromium, copper, like little harder metals. Some metals, when we involve with some metals, there are multiple valencies. They have more than one valency. So that time we can't buy hard. So they will help us like this way. See the method I explain it. They ask you to write the formula of iron in brackets 3 in Roman figures, iron 3 oxide. Iron 3 oxide. Iron is Fe. This 3 means you no need to buy hard the value. 3 means the valency of iron. So valency of iron, you know to buy hard. In exam, they will give iron 3 means valency of iron. Oxide's valency, you remember, it's minus 2. So it is 2 and cannot be simplified again. 2 and 3 cannot be divided. So then Fe gains number 2. Oxide gains number 3. That's how we write iron 3 oxide. Right. Iron and oxygen. Iron 3 means the valency of iron, oxide valency 2. So they interchange. So Fe2O3 comes. I'll come to another example. Right. My next example is copper 2 nitrate. Copper 2 nitrate. Copper is Cu. Valency now you know. That's 2. Nitrate is familiar to you now. NO3 minus. Valency 1. So we interchange. Copper gains number 1, nitrate gains number 2. Or it's something like a 32. So why don't you put a bracket? So that's what copper nitrate, copper 2 nitrate. That's how we write the copper 2 nitrate. Right. Now I will go to another example. This is how the copper 2 nitrate comes. Then I go to some other thing, that hydroxide. Okay. This time potassium hydroxide. Okay. Potassium is K. Hydroxide is OH minus. Potassium's valency 1. Hydroxide valency 1. The valency sign interchange. So potassium gains 1. Don't write it. Hydroxide gains also 1. KOH. So they are interchanged like that. Okay. Then I go next one. I guess you write it if you want. You can pause the video and you can write it up. Right. The next one, magnesium. Magnesium hydroxide. Magnesium is Mg, hydroxide is OH minus. Magnesium's valency 2, hydroxide valency 1. So we interchange. Magnesium gains 1. We don't write. Oh, hydroxide gains number 2. So we put a bracket 10. Magnesium hydroxide. That's how we work it. Right. Then I go to this one. We say that nickel to hydroxide. Nickel, you can copy it from the periodic table. Nickel is Ni. Hydroxide is OH minus. Nickel's valency is given here. Nickel's valency 2. Hydroxide is 1. So we interchange. So nickel gains number 1. Hydroxide gains number 2. Right. So now this is how we write the chemical formula. The chemical formula is very, very important. Contents. That is because without chemical formula, we can't symbolize substances. We can't symbolize the compounds. Like how we need an alphabet in chemistry, this chemical formula works like an alphabet. So I guess you understood how to simply construct the chemical formula. So then I guess my next video I'll come with a somewhat little advanced part of that. Okay, then thank you very much for joining.